Okay, nice. Okay, guys, in this section we start a new MCQ, a new set of MCQs, and I remind you that this is just the video recording my lecture online. So anytime there will be some questions, and I will try to give the answer. Before giving the answer, I will repeat the question so that you can also understand what was the question. Okay, so we are given here the first question is the following. The question says, let f of x be equal to 2 over x minus 2 squared. A primitive of f of x for x greater than 2 is. So what is to find the primitive of a function, we need to integrate it. Okay, so we do the integral of 2 over x minus 2 all square in dx. Okay. So what is look, when you want, this is what we call when we integrate without the boundaries. Okay, we are finding primitives. Okay, so what is to integrate this, you can write it like the integral of, if you want, 2 multiplied by x minus 2 all to power minus 2 in dx. It's the same, right? I can take the 2 out, so it's 2 multiplied by integral of x minus 2 to power minus 2 in dx, because the constants can move out from the integral. Now I remind you by doing this very important formula of the integration calculus, saying that if you have the integral of f prime times f to power n, this will give you f to power n plus 1 over n plus 1. It's a fundamental formula, so guys, make sure that you keep it in mind. Okay, anytime you multiply f prime by f to power n, the integral of this is f to power n plus 1 over n plus 1. So we can going back here to our integration. Okay, this integral can be written again like 2 times the integral of 1 multiplied by x minus 2 to the power of minus 2. What is this 1? So here, what is f? This is f. This is f to power minus 2, right? And if this is f, x minus 2, this 1 will be f prime, right? So we are basically doing the integral of f prime times f to power minus 2. By this formula, it will give of f to power minus 2 plus 1 divided by minus 2 plus 1, and thus it will give of f to power minus 1 divided by minus 1. Okay, in our case, what is f? So this integral here we give of 2 multiplied by f is x minus 2, so x minus 2 over to power minus 1 all divided by minus 1. Okay, all this plus a constant, because we are, remember that the primitive, when we are solving for the primitive, you have a single function plus any constant, right? So this gives you we can rewrite this like, we can divide this like minus 2 over x minus 2. It's clear for all of you? It's clear for you? Okay, so it will be minus 2 over x minus 2, okay, plus the constants. But if I go back and I don't want all, look, that what we are saying is that all the possible primitives are minus 2 over x minus 2 plus any constant, because this is for any constant belonging to R, right? It works for any constant belonging to R. Good. But we want a primitive, not all of them, right? We want one of them. So we should find the value of C. We should find the value of C that gave us one of this answer. Is that clear what we want to do? If we found all the possible primitives that depend on one constant, okay, but we just want one of them, so one given some value to c, we should get one of these possible functions. In order to do it, let's write down this stuff like minus 2, okay, plus cx plus 2c over x plus 2, right? If what do you see? You see that we have x minus 2, 2 minus x. But if we are willing to stay with only x at the numerator, how should you try to put, what should be the value of c? Okay, but the problem is that if you put 1, there will be okay, you will stay with, if you put 1, there will be minus 2. Okay, yes, let's try to put 1. But I was right, I put all the stuff correctly. This was x minus 2, so I did a mistake here. This is minus 2. Fact, yes or not? I made a mistake here, and nobody told me nothing. So this was this is also here is minus, right? Okay, minus. So in fact, if I want to stay with x at the numerator, I can try to say, okay, let's put c equal to 1. But if I put c equal to 1, I will get minus 2 plus x minus 2 divided by x. Also this one is minus 2. But you see that it will give me x minus 4 over x minus 2. That is not one of the answer, right? So let's try with minus 1, because it's the only other it's not the only other possibility. I will try by minus 1, because with minus 1 the number will cancel. Yes or not? So if I put c equal to minus 1, I get minus 2 minus x plus 2 over x minus 2, right? So it gives me minus x over x minus 2. But this I can multiply by minus up and minus down. It is x over 2 minus x, right? So the answer is B. So we have 1B. Doubts? Okay. What is the structure? The basic structure of the problem is the following. The basic structure of the problem is they ask us about the primitive for x greater than 2. But this primitive that we get, should we care about this condition? This primitive that we get, you saw that this primitive is for all x different than 2, because x cannot be 2, right? So if somebody asks me the primitive for x greater than 2, and I find a primitive for all x different than 2, it's clear that if this is the primitive for all x greater than 2, it's for all x different than 2, it is also a primitive for all x greater than 2. Is that clear? Nice. Okay, next question. The next question says, given f of x equal to 2x plus 1 over x squared plus x squared, and f of x a primitive of small f of x in 0 plus infinity, such that f of 1 is equal to minus 1/2, then, so once more, we want to find the primitive. But we want to find the primitive that satisfies a specific condition. Okay, we want to find the primitive that satisfies f of 1 equal to minus half. So let's go on the let me clean directly and take a new one. So what is the function? The function is f of x equal to 2x plus 1 over x squared plus x whole square. So f of x equal to 2x plus 1 over x squared plus x all square. Now big f of x, or the big R, the integral of 2x plus 1 over x squared plus x all square in dx. Now keep in mind that, as I told you before, you can directly see that what is the derivative of this one? What is the derivative of x squared plus x? What? Yes, 2x plus 1, right? So we can see that we can rewrite this integral like integral of 2x plus 1 multiplied by x squared plus x all to the power minus 2 in dx. So one more, I recognize that this is f prime, this is f, no, this is f prime, and this is f, right, to power minus 2. So once more it will be f to power minus 2, f to power minus 2 plus 1 divided by minus 2 plus 1. Okay, so the result of this integration will be f, which is x squared plus x to power minus 2 plus 1, which is minus 1, divided by minus 1. Okay, this will be minus 1 over x squared plus x. So we got that f of x is minus 1 over x squared plus x plus c for any constant c belonging to R, right? These are all the primitives, yes or not? But we want the primitive that satisfy the condition f of 1 equal to half. Okay, this was the condition, not to minus half. This means that these are all the possible primitives, but I want the one that satisfy the condition f of 1 equal to minus half. So I go and I plug, so f of 1 equal to minus half means that, what is f of 1? Minus 1 over 1 square plus 1 plus c should be equal to minus half, yes or not? I plug x, this is f of 1, doubts? This is f of x is this, doubts? So I mean, now it gives you minus 1 half plus c equal to minus 1 half. So c is equal to 0. And if c is equal to 0, I finally get that the primitive that I want is the one with c equal to 0. So it is then minus 1 over x squared plus x. But if I check here, it seems like I don't have it. I need to check the one that map to it. Let's start from, it cannot be for sure but the answer cannot be e for sure, because the answer should not have the constant. The answer cannot be d. So the answer is between a, b and c, right? So let's go and start for we check for a, which is 1 over x plus 1 plus 1 over x, right? Just to, if it's minus 1 over x, to see if it's the same thing. If we do, the denominator will be x squared plus x, right? And it will be x minus 1, right? That gives us exactly minus 1 over x squared plus x, yes or not? So we get exactly what we were expecting to get. So the answer is A, right? So it's 2A. Is there any question? So how do you, the question of my student is, how do we get to repeat the computation of the denominator or the numerator? Okay, so we want, basically is we want to repeat this So when I want to sum up two fractions, I first multiply the denominators, right? So it will be x squared plus x. Then I do this time, okay. So is that clear? Okay, nice. The answer is 2A. Okay, we will proceed. We will keep solving in the next video. Okay, if there are some questions, some observation to make, that something that we didn't understand, please write in the comment section.